Hello viewers, we're taking you through the story of A-level pure mathematics, and this video we're going to go through the marking guide of mock set 1 of one of the schools where I happen to be a teacher. So this video is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So question 1 says solve for the value of x, and this is the equation. So I think realize that these are three square roots. There is this one, there is this one, and there is this one. The misconception students do is to square each square root independently. That is not okay. What we do, we square both sides. So shall put this in brackets and square it as you see it here, and also put this in brackets and square it as you see here. Then from there we have to expand. When I expand this, I'll come up with this part. Then when I expand this, the square root goes away to remain with this. After that, you realize that we still have a square root here. So shall put the rest the other side and remain with the square root on one side. Then after that, we shall now square both sides again. When we square both sides, we shall come up with this. So think rather this was 2, now it is 4. Then this one, the square goes away. And this one, you square it to come up with this. The next is to collect like terms and then solve the quadratic using either bulldozer or factorization, but bulldozer is easier. That means that x is equal to negative a third or x is equal to 1, and that is what they wanted. Then question 2 says find the Cartesian equation of the locus z of this. So here we shall let z to be equal to x plus yi. Then we shall come here and substitute for z. Then we substitute, we shall rearrange. So real part alone, there is this x and also this 2. Imaginary part, there is this y and also this 1. Then magnitude means you get square root, but this, when you get the square root, some students, what they do, they maintain this I here, but that is not allowed. So magnitude, you don't put this I. You just put the real part and imaginary part. Then square both sides to come up with this step. Expand and then rearrange. So this is the locus they wanted, and it is the locus of a circle. They only wanted the Cartesian equation, so that's why we stop. Then question 3 says a cable 10 meters long is divided into 10 pieces whose lengths are in a GP. The length of the longest piece is 8 times the length of the shortest piece. Calculate to the nearest centimeter the length of the third piece. So here we shall let the first piece, we shall let the first term A be the shortest piece and the last term mu 10 to be the longest piece. We know that the nth term is given by this expression, and also the sum of the first n terms of a GP is given by this expression. Therefore we are given, that means that the 10th term will be 8a. Now why is it 8a? It is because of this word 8 times the length of the shortest piece. And he already said let the shortest piece be a. Therefore 8 times a gives you 8a. Then here we shall say that from here the 10th term, using this formula, the 10th term will be a r to power 9, which is here. Then we shall equate it to 8a. Then cancel the a to remain with r to the power 9 equal to 2 to the power 3. Therefore, when I reduce, it becomes r cubed equal to 2. That is when I multiply both by power of 1 over 3, power of 1 over 3, I'll come up with this. Therefore, r is the cube root of 2, which is this. Also, the sum of the first 10 terms is 10, because they told us the cable is 10 meters long and is divided into 10 pieces, meaning the total sum must be equal to 10. So we shall come and substitute using this formula. A is here, r, we have got it here. We shall use this one, which is not a decimal, which is here. Then n, there are 10 terms because they are divided into 10 pieces. So this n will be 10. Then r, still use that, equal to 10. So when I use the calculator, the whole of this will give me this. And that means I can get the value of a as that. Now the question wanted to the nearest centimeter the length of the third piece. So the length of the third piece is mu3. So mu3, using this expression, it will be ar squared. So the value of a is this, then substitute for r, it is squared. So when I use the calculator, this one will give me this, but it is in meters, so I have to convert to centimeters. But remember, they said to the nearest centimeter, therefore nearest centimeter will be 45 centimeters, and that's what they wanted. Then question 4 says solve the equation this for alpha ranging from negative pi to positive pi. So I can use our formula, so this one will be equivalent to this. And when I expand this, I'll come up with this. So by comparison, we have cos alpha here and cos alpha here, meaning this 2 will be equal to r cos beta. Also, sin alpha here, we also have sin alpha here, meaning 3 will be equal to r sin beta. So we'll come and write those ones. Then we divide them to get, so this cancels to remain with sine over cos, which is tan, and 3 over 2 is 1.5. Therefore, beta will be 56.31. We use 2 decimal places. And r will be got by saying this square plus this squared everything under root to give you root 13. And now that I have got the value of r and the value of beta, I can come and express this in terms of this. Okay, therefore, this given equation here, I'll come and replace the whole of this with this. So let me do that. Then from there, I'll get this one and take it the other side. And then get arc cos of the whole of this angle. So the angle, it is undefined. So why is it undefined? Because this value is greater than 1, yet cos is maximum at 1. So that is why we stop, because we cannot proceed any further. Then question 5 says, using small changes, show that this is equal to that. So what we shall do, we shall let y equal to x power 5 and y plus small change in y be equal to x plus small change in x power 5. And the whole of this is now this one which is given here. Then the whole of this is this one which is given here. So that means that to get this value, you have to get y and the value of small change in y. So if x is 243, then small change in x will be the difference, which will be 1. And y from here, y will be equal to this, 5th root of 243, which is 3. So we have got the value of y, but we have not yet got the value of small change in x. So to get the small change in x, we shall say that we shall compare it with dy dx. So let's first get dy dx. So dy dx is got by differentiating this to come up with 1 over 5 x power negative 4 over 5. But I already know that x is 243, so come and substitute for x to come up with 1 over 405. Then from there, remember that small change in y approximates to this approximation sign has been seen. dy dx times small change in x. That will come and substitute for dy dx and also substitute for small change in x to come up with this as a small change in y. So now that I have small change in y and y, I can get the value I want. So this will be equal to y plus small change in y. Substitute for y, substitute for small change in y to give you this as the answer they wanted. So now we shall go to question 6, which says solve the simultaneous equations, these ones. So we shall come and say that from this first equation, make y the subject to give you that. And from this second equation, you can first eliminate logarithm by first putting this one up, because there's no way you can remove this log when there's a coefficient here. So first take it up to give you this part. Then also remember that y is equal to 2 over x, which is this. Then from there, I can now eliminate this log and remain with these ones. After that, I can open brackets for expand this to give you this. Then multiply, cross multiply to give you this. Then rearrange to give you that. Now here I have 2 factorized, but we don't use calculators. What we do, shall let fx be equal to this expression here. Then from there I will say that if I put if x is equal to 2 and I substitute it where there is x, I realize that I come up with 0. So what does that mean? It means that x minus 2 is a factor. Therefore now by synthetic, you can either use long division or synthetic method. So if I choose synthetic method, I'll come up with that. So how does it come about? First of all, this x is equal to 2 is what you put here. Then here, this line, you put the coefficient of this fx. Here coefficient is 1, here is negative 2, here it is 1, here it is negative 2. Okay, then from there, bring this one exactly here. That's the first part, so that's where this one is coming from. Then from there, I will say 2 times 1, what do I get? I'll get 2, so that 2 is what you write here. Okay, then from there you add this plus this gives you 0, that's what you write here. Then again repeat the process. 2 times 0 gives you 0, you put it here. Then 1 plus 0 gives you 1. Okay, then again you repeat the process. 2 times 1 is 2, you write it here. The negative 2 plus 2 gives you 0. So that is synthetic method. Therefore, fx will be equal to this factor multiplied by this one. Now here we have, these are the coefficients of the quadratic which comes out. Coefficient of x squared is 1. Coefficient of x is 0. That is why you don't see here any term of x. Then coefficient of the constant is 1. This 0 means that the remainder is 0. So we have factorized. After factorizing, we can go back now and answer the question. So we were given this, meaning that the whole of this is equal to 0. But this one equal to 0 has no real roots. Therefore, x will be equal to 2. After getting x equal to 2, I'll remember that y is equal to 2 over x, meaning that y will be equal to 2 over 2, which is 1. And that's what they wanted. Then question 7 says, if the x and y axis are tangents of the circle, this show that c is equal to g squared and is equal to f squared. So this is the equation of the circle. Considering y tangent y equal to 0, remember they said this is a tangent and this is a tangent. Therefore, for the x-axis, y is equal to 0. For the y-axis, x is equal to 0. So y equal to 0, I'll come and substitute where there is y, I'll put there 0 to remain with this. Then condition for tangency, b squared minus 4ac is equal to 0. So b squared is that. Then 4a, 4 is that. A is this quotient, which is 1, and c is this one, which is here. So I'll simplify and get c equal to g squared. That is equation 1. What about for the other tangent, which is x equal to 0? Come and substitute where there is x, put 0. Then do the same for tangency, b squared minus 4ac is equal to 0. Substitute for b, a, and c. Simplify and come up with equation 2. So I have two equations and all are equal to c. Therefore, c is equal to g squared and is equal to f squared, and that's what they wanted. Then question 8 says, solve the equation this. So first state, then I have to change the base. This is base 3 and here the base is x, so I'll have to change to one base. So if I change to base 3, I'll come up with the reciprocal here, and then let y be equal to log x of log base 3 of x. And then substitute here, put y, here put y. Multiply followed by y, get a quadratic. Then you have to solve it using either bulldozer or factorization, and the value will be that. Then from there, I'll remember that y is equal to this. Therefore, log base 3 of x will be equal to plus or minus root 3. That means that x is equal to 3 to power, so x is equal to 3 to power this. And there I can use the calculator to get the two values of x, and that's what they wanted. Then question 9, say part A says, if z1 is equal to this and z2 is equal to this, find this. So let's first begin with part A. So z1 minus z2, I'll get z1, get also z2, then get its LCM. LCM is this. So this LCM divided by this, you remain with 5. 5 times 2i gives you this part. Then again, the LCM divided by 5, you remain with 1 plus 3i times this to give you this part. The next is to expand the numerator. Expand this numerator to give you this, and simplify to give you this. Then from there, I cannot leave an imaginary part in the denominator, so I have to rationalize or realize by multiplying by conjugate of the denominator both up and down, just as you see it here. Then again, you have to expand. For the numerator, I'll come up with this. For the denominator, this 5 is maintained, and this will be difference of 2 squares to give you this. Note that we are using plus, not minus, because I squared is -1. Then simplify the numerator to come up with this, simplify the denominator to come up with this, and in the end you'll come up with this as the value of z1 minus z2. But they wanted magnitude, so magnitude means, in this case, since it's only one term, it means that what is negative becomes positive to give you 1/5 units. Then part B said, given the complex number z equal to x plus yi, Roman 1, find this, and Roman 2, show that the locus of this is a straight line when its imaginary part is 0, and state the gradient of the line. So let z be equal to x plus yi. Then come and substitute for z to give you this and rearrange. Then from there I have to rationalize because the denominator has an imaginary part, so I have to rationalize to give you that. Then expand both the numerator and denominator. So for the numerator I'll come up with this, denominator I'll come up with the difference of two squares. So I expand further this bracket to come up with this, and also expand this to come up with this, and this to come up with this. Then expand further to come up with that, and that would be the expression they wanted. Then for Roman 2, they said, show that the locus of this is a straight line when its imaginary part is 0, and find its and state its gradient. So imaginary part is 0. So what is the imaginary part? It will be the whole of this, because this denominator works for both real and imaginary part. So it is 0, you cross multiply, then you can make y the subject, and that will be the equation of the tangent. So it is a straight line because it is in the form y equal to mx plus c. Then they told you to state the gradient, so gradient will be -1/2, and that's what they wanted. So that was question 9. Now we shall go to question 10. Part A says, solve the equation this for values of x ranging from 0 to 180 degrees. So let's start with part A. So this is what is given, so we shall come and write it there. Then this is from double angle formula. This one is the same as 1 minus 2 sine squared x. I think you see that the angle has reduced by 1/2, so it was 2x is now x. Then from there we realize that this and this can cancel, so this side will remain with 1, this side will remain with this. So when I make cos x the subject, I'll come up with cos x being equal to plus or minus 0.5. And when I get a cos, I'll come up with 60 degrees and 120 degrees. So cos is positive in the first quadrant and in fourth quadrant. But because the range is from 0 to 180, we shall take the angle in the first quadrant, which is 60. Then also cos is negative in the second and third quadrant. But because the angles range up to 180, we shall take only the second quadrant angle. So that's why we have 60 degrees and 120 degrees. That is part A. Then for part B, they said, show that if this is equal to this, then tan x is that, and hence solve the equation this for x be ranging from 0 to 180 degrees. So this is what is given. We shall first expand using compound angle formula. This gives that, and this is that. Then we shall divide throughout by cos x. So this by cos x gives you tan x, cos alpha. This one cos cancels away, you remain with sin alpha. Here it gives you tan x, there is p, there is cos alpha. Here the cos cancels out, you remain with p sine alpha. Then you rearrange, put the tan x alone, so take this one this side and bring this one this side to come up with this. Then from there you are going to factorize out, because this is sine alpha is common, so pull it out, you remain with what, p plus 1. Here tan x cos alpha is common, pull it out, you remain with p minus 1. Then from there, this cos alpha will go this side, so sine over cos will give you tan alpha. Out of that, my aim is to make tan x the subject, so tan x will be equal to this, and that's what they wanted. So the hence part, they said hence solve this equation for the values of x ranging from 0 to 180. Hence means we start from here. So what does this mean? It means that alpha is equal to 20 degrees, p is equal to 2, and yeah, alpha is 20, we have already seen that. So alpha is 20 degrees and p is equal to 2. So we shall come and see that for the hence part, from this it means that p is 2 and alpha is 1 is 20 degrees. Then we come and substitute for p and for alpha, then simplify and then use a calculator to come up with this as the value of x. Then question 11 says, given that x is equal to this and y is equal to this, find the second derivative of y with respect to x. So here we shall say from x dx dt we shall use quotient. Now quotient says that keep this one constant, which is here, then differentiate the numerator, which is 2t, minus keep the numerator constant, which is this, then differentiate the denominator, which is 3t squared. Everything divided by the denominator squared. Okay, so there we have differentiated, but we have to simplify. So simplifying this one, I'll come up with this is this, this with this is this, then this with this is this. Then here it remains, don't tamper with it. Now here this and this can collect like terms to give you negative t to the power 4, but there's 2t here. Then here t is common, factorize it out. So that is dx dt. What about dy dt? So dy dt still we use quotient rule, so it will be keep the denominator constant, differentiate the numerator, minus keep the numerator constant, differentiate the denominator, divided by the denominator squared. Then we simplify, expand this times this, this times this, this times this, then denominator is maintained. Then from there, this cancels with this, you remain with this alone in the numerator. Therefore, by chain rule, dy dx will be dy dt times dt dx. So dy dt is this, and dt dx will be this reciprocal. Then from there, you realize that this and this cancels, so numerator remain with this. Oh yeah, even this t cancels with 1t, so numerator remain with 3t, and denominator remain with 2 minus t cubed. That is first derivative. What about second derivative? Second derivative, we are going to first differentiate this with respect to t, then you multiply by dt dx in order to get the second derivative of y with respect to x. So if I differentiate this one, I'll use quotient rule still. keep the denominator constant, differentiate the numerator. Then minus, keep the numerator constant, differentiate the denominator, divided by the denominator squared, and multiply by dt dx. dt dx, we already saw it that it is this. So we have differentiated, but we have to simplify. So simplifying, I'll come up with this. Then from there, this and this becomes this. And this one is here. Then this and this becomes this. So this was square, this was power 1, so it becomes cubed. Then here I can factorize out 6 to come up with this. Then from there I can say that this and this can combine to give you cubed. And that's what they wanted. Then question 12, part A says the sum of n terms of a series is 2 to the power n minus 1. Roman 1, show that the terms of this series are in a GP. And Roman 2, hence find the first term, the common ratio, and the sum of the second set of n terms. So let's first deal with part A. So A Roman 1, first of all, Sn, the sum of first n terms is given by that, meaning that the first term will be good by substituting n equal to 1 to give you this. Then the sum of the first two terms will be good by substituting n equal to 2 to give you that. The sum of the first three terms will be good by substituting n equal to 3 to give you this. Sum of the first four terms will be 15. What does that mean? It means that for you to get the first term is already the sum of the first term, which is 1. But the second term will be got by subtracting the first term from the sum of the first two terms to give you 3 minus 1, which is 2. What about the third term? It will be S3 minus S2 to give you 4. Fourth term will be S4 minus S3 to give you 8. So now I can say that the ratio of the second to first is 2, ratio of the third to second is 2, ratio of the fourth to third is 2. That means that because there is a common ratio, then the series is a GP. So that was Roman 1. Roman 2 said, hence find the first term, the common ratio, and the sum of the second set of n terms. So for the second set of n terms, first term will be n plus 1, which is given by subtraction to give you this. So I can simplify further. So this one, this minus that gives you this, and this cancels. So this and this one alone is this, laws of indices. Then 2 to the power n is common. So I'll factorize it out and remain with 2 here and 1 here to give you 2 to the power n. So that's the first term for the second set of n terms. Common ratio is 2, so it is maintained. Therefore, and we know that Sn is this, implying that the sum of the second set of n up to the second set of n terms is that. That means that the sum of the second set alone, remember this Sn2 is from n equal to 1 up to n. Okay, then this Sn is from n equal to 1 up to n. Now if I want from n plus 1 up to n, up to 2n, it means I'll subtract. So s2n minus sn, and to give me the sum I want. So this minus this cancels, you remain with this. Then we can rearrange this one to become this, then factorize out 2 to the power n to remain with this. And that is what they wanted. So that was part A. What about part B? So for part B, we shall say that from a group of 6 boys and 4 girls of the science club, 5 members are to be selected to represent the club in a science workshop. In how many ways can the selection be done if, Roman 1, there must be exactly 2 girls in the science club? Then Roman 2, 1 boy and 1 girl must be in the science workshop. So the number of ways of selecting so that there must be exactly 2 girls in the science workshop will be that. So 2 girls. So from 4 girls you pick 2. Then the other one will come from the 6 boys, which is 3. To give now 4 combination 2 is 6, and 6 combination 3 is 20. Multiply the 2 to give you 120 ways. Then Roman 2. The number of ways of selecting so that 1 boy and 1 girl must be in the science workshop. So here, what does that mean? It means that you already have 1 boy, so out of the 6 you already removed 1, you now have 5. Then here I already have 1 girl, so out of the 4 you now have 3 to select from. That is why you are seeing here 3 instead of 4 and 5 instead of 6. Okay. So from these ones now, I need 3 because I've already got 2, 1 boy, 1 girl. So I need to select 3. So I can select 0 girl and 3 boys, or 1 girl and 2 boys, or 2 girls and 1 boy, or 3 girls and 0 boys. So you use the calculator. This gives me 10, this gives me 30, this gives me 15, and this gives me 1. And then I'll come up with 56. So that was question 12. Now we shall go to question 13. Question 13 says, show that the lines this and this do intersect. Let's first show that. So if these lines intersect, it implies that R is equal to P. Then we'll come and equate the two. Then from this first line, I'll come up with this equation, implying that T is equal to that. From the second line, I'll come up with that equation. Therefore, when I substitute for T in equation 2, I'll come up with this. So M is the only unknown. So I'll have to look for a way of making M the subject, and M will be -1. When M is -1, it means that from equation 1, T is equal to 2. Now substituting for T and M in Roman 1 gives me this. So I'll come here and substitute for T, substitute for M. Simplify, and I'll come up with this when they are equal, meaning that they intersect. Then hence find the position vector of their point of intersection. So position vector, we are going to just state this. That was part A. Then the angle between them, there we use the direction vectors and dot product. So yeah, the direction vector of the first line is this, second line is that, therefore we shall come and use dot product. Cos theta is equal to d1 dot d2 over magnitude of d1 magnitude of d2. Therefore come and substitute. Simplify and get the value of theta. That was part B. What about part C? Part C, they want the Cartesian equation of the plane formed by the two lines. So for you to get the Cartesian equation, you need a normal vector. So the normal vector is got by crossing the two vectors, direction vectors, this and this. So when I cross, I come up with this. So how do I generate this? First of all, this is 313, so I'll come and write it horizontally, 313. Then this is 425, I'll come and write it horizontally, 425. Then up there is ijk. So from there, it means that if I extract out I, it means I'll ignore this one and write this, which is here. Okay. Then minus, extract out j and ignore j, then write this and these ones, which is this. Then x plus, so it was plus minus plus, so plus k, remove k and extract out I and j. Then from there, it's like getting the determinant. Major diagonal minus minor diagonal. So this times this is 5 minus this times this, which is 6. Then here this times this is 15 minus this times this, which is 12. This times this is 6 minus this times this, which is 4. Simplify and that will be the normal vector. Then I also have this position vector. Therefore now I know the normal vector and position vector. Therefore I can get the Cartesian equation of the plane from the formula that r dot n is equal to n dot a. Then substitute, expand, simplify, and that is what they wanted. So you can rearrange to make x positive. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on solution marking guide for senior 6 math paper 2 of mock set 1. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded.